Welcome to the Privacy Report. Today we're diving into a massive change happening to the Internet's core infrastructure. It's the shift to IPv6. Now, this is the protocol that literally saved the Internet from running out of addresses. But, and this is the big question, it might have accidentally created a way to permanently track billions of devices.
That is the core tension, isn't it? I mean, we had the system IPv4 that it ran out of road. We hit the limit of about 4.3 billion addresses.
Which sounds like a lot, but it's really not anymore.
Not at all. And so we moved to IPv6, which has an address pool so vast, it's effectively infinite. So we solved one crisis, the capacity crisis. But the default settings, that's where the hidden cost is, a cost most people just aren't aware of.
And that upgrade was, it was completely necessary. When you think about every phone, every smart thermostat, all the IoT sensors.
Everything is connected.
Exactly. The old system just couldn't handle it. The IETF, the Internet Engineering Task Force, they had to make that jump from 32-bit addresses to 128-bit. So I guess the question we have to explore is, did we end up trading capacity for our anonymity? Before we dig right into that, just a reminder that you can subscribe to our weekly newsletter. We share configuration tips and privacy news over at theprivacyreport.net. Okay, so let's start with the basics here. Why was this about more than just needing more numbers? How is IPv6 actually, better?
Well, it's simpler. Fundamentally, under the hood, it's a much cleaner design. It streamlines how data packets are handled. There's less fragmentation. And it gets rid of some of the clunky workarounds that IPv4 needed just to keep running.
So devices can communicate more directly? Is that the idea?
That's it. They talk more directly, which cuts down on waste and makes network routing far more predictable, especially on a global scale.
So it's not just a bigger bucket for addresses. It's actually a more efficient system. The numbers are just one piece of a much larger efficiency puzzle for the whole Internet.
Exactly right. The design is cleaner, and that leads to better performance. It just makes managing massive networks easier for everyone.
Okay, so here's the part that feels, counterintuitive. You hear new protocol, and you immediately think better security, more modern. But you're saying IPv6 has a feature that, if you don't check it, makes tracking incredibly easy. What is that weak point?
It all comes down to how your device gets its address. It uses a process called SLAC. That's stateless address auto-configuration. And in a lot of default setups, SLAC uses a piece of your device's permanent hardware identifier.
You mean like the MEC address?
The equivalent of it, yes. It uses that to build the public IPv6 address your device uses to talk to the Internet.
Hold on. So you're saying the unique address assigned to my laptop could be based on its unchangeable hardware ID. That would mean the address is permanent, it's globally unique, and it follows me across every coffee shop, Wi-Fi, every network I ever join.
You've got it. It completely bypasses the temporary anonymity we used to have. If that address never changes, it's basically the holy grail for anyone trying to do long-term tracking and profiling.
Wow.
But the designers saw this coming. They did. And they built the fix right into the protocol. It's called privacy extensions.
Okay.
And these extensions basically just tell the system, hey, don't use that permanent ID. Just randomize this part of the address constantly. They create temporary, frequently changing addresses instead.
So the tool to protect us is right there. But the catch is that not all operating systems or, devices turn these privacy extensions on by default.
That's the critical point. They're implemented inconsistently. So you could be exposed unless you actively go in and configure the solution yourself.
So configuration is everything.
It's absolutely everything. You can't rely on the defaults, especially because we're moving away from the old world of NAT, or network address translation. NAT was like a shield. It hid all your devices behind one single public address. Without that shield, your device is just out there directly on the Internet with its own unique address.
Okay, that makes this really urgent. We need to go through a checklist then. If configuration is what determines our exposure, what are the 5 most important things we need to check right now? Where do we start?
First thing, number 1, you have to verify your privacy extension status. You need to go into your device's network settings and confirm that it's actually generating those temporary randomized addresses.
And not the permanent one based on the hardware.
Exactly. That is step 1. It's the most important thing for stopping that long-term device profiling.
Okay, what's step 2? Is it just about the address being random, or does it matter how the network is even assigning them in the first place?
It does. Step 2 is to confirm your address acquisition method. You need to know if your network is using that potentially risky SLAC we mentioned, or if it's using something called DHCPv6. Understanding that just tells you how much control the network has over the addresses it hands out.
Now let's talk about the router. My firewall. For years, I've just counted on it to be my first line of defense, and it was usually on by default for IPv4. Why do I suddenly have to worry about my IPv6 firewall settings?
That's a huge one, and it's the third critical step. Review your router and firewall IPv6 policies. You're right, your IPv4 firewall is probably pretty solid. But a lot of manufacturers during this transition are shipping routers that treat IPv6 traffic with, well, with far fewer filtering rules, or sometimes none at all.
So they just open the floodgates for the new protocol.
And if that happens, you've just exposed every single device on your home network directly to the public internet because that net shield is gone.
That is a massive silent vulnerability, and it can happen just from a firmware update. What about the providers themselves? Are they logging this new globally unique traffic the same way?
Which brings us to point 4, logging settings. Because IPv6 addresses are so specific and potentially permanent if they're not randomized, ISPs might be storing logs and metadata differently. The address is tied to your device, not just your house. So those data retention policies could be way more revealing about what you do over the long term. It's worth checking your provider's policy.
Do a final one. The essential risk for anyone using tools like a VPN to protect their identity. How does IPv6 mess with that?
Fifth, and this is crucial, VPN leak testing. Almost every network today is in what's called a dual stack environment. That just means it runs IPv4 and IPv6 at the same time. A surprising number of VPNs only secure the old IPv4 connection.
Oh, I see where this is going.
Right. If that happens, your IPv6 traffic can just leak. It goes right around the secure tunnel, exposing your real IP, your real location. You have to use a VPN that explicitly handles or safely disables IPv6 to prevent that.
So if we look back at the big question, does IPv6 make tracking easier or harder? The answer is really, it depends on you, isn't it?
Completely. When you are diligent about it, you enable privacy extensions, you lock down your IPv6 firewall, you are actually more private than you were before. But if you just stick with the default, you've made long-term global tracking of your specific devices much, much simpler. It all comes down to configuration.
And we are still mostly in this dual stack world, so it's a gradual change. But the fact that IPv6 removes the need for NAT, that's a monumental shift in our default privacy posture.
It really is. NAT was, like we said, an accidental privacy feature born out of IPv4 running out of space. IPv6 removes that barrier, so you, the user, have to be proactive. Keep your OS updated, make sure your router's firmware supports a good IPv6 firewall, and use online tools to test your connection for those IPv6 leaks, especially if you're on a VPN.
So here's the final thought I think we should leave everyone with. The move to IPv6 was essential. It solved a foundational crisis and allows the internet to keep growing. But the security features built into it, like native IPsec support and those critical privacy extensions, they aren't on by default. They are levers that you have to pull yourself. The future of the internet's architecture is here, but the job of securing your identity within it is now. Well, it's on your shoulders.
You just can't assume that modern technology automatically comes with modern privacy. Go check your settings.
A perfect call to action. Thank you for joining us for this investigation into the next generation of internet privacy. If you found this information useful, please remember to like and subscribe to the podcast wherever you listen so you never miss a report.
Thank you for tuning in.
This episode was made with the assistance of AI.